Now let's turn to traversal. That just means walking the list from front to back and visiting every node in order. It is the first thing we do with a list, so let's see how the walk works. Before I show you the answer, let's think together. To visit the list, we start at head. Then we repeat one simple step, cur becomes cur arrow next. Each time, cur hops to the next node. This is the first question. What value must cur reach for the walk to know it is finished? In other words, what tells us there are no more nodes? Second question. On this chain, 10 arrow 20 arrow 30, how many nodes get visited before the walk ends? Count them in your head. And then watch the cursor. It will hop across scattered addresses in memory, not neat neighboring slots like an array. This is the trap to avoid. You may think the list knows its own length. It does not. There is no counter and no last index. The only sign that you have run out of nodes is a next field that holds null. So take a moment and commit to your answers before the next slide. Now let's watch the walk, one hop at a time. We start at head and follow next again and again. Amber marks where the cursor is right now. Indigo marks nodes we have already visited. The walk stops at null. First hop. Cur holds the address hex 3000, so it points at node 10. We visit 10. Then we run cur becomes cur arrow next. Node 10's next field holds hex 7000, so cur now moves to node 20. Second hop. Cur now holds hex 7000, pointing at node 20. We visit 20. Node 10 is done, so it turns indigo. Then cur becomes cur arrow next again, and 20's next holds hex 4200, so cur moves to node 30. Third hop, we visit 30. Now node 30's next field holds null, so cur becomes null and the loop stops. All three nodes are visited. Notice the null at the tail is the only thing that ended the walk. There was no length counter, only that null. This is the walk written in C. The for loop is the whole traversal, so this operation is C only. We start cur at head. We keep going while cur is not null, and after each node we run cur becomes cur arrow next. Inside the loop we print cur arrow data. The moment cur becomes null, the loop stops. Let's look at the cost. Time is big O of n because we touch each node once. Space is big O of 1 because we only keep a single cursor. Compare an array where A of I jumped straight to any element with simple address math, big O of 1. A list has no such jump. It must walk. That is the core trade-off, and it comes back for every operation. Now the learning check. The loop tests cur is not null. What breaks if we write cur arrow next is not null instead? Two things break. We stop one node early, so the last node is never printed. And on an empty list, head is null, so cur arrow next reads through a null pointer and crashes. So always test cur first before you touch cur arrow anything.